Hi everyone, I am Sindhuja. I am currently pursuing third year BTech in SRIT Engineering College, and now I am going to explain about the interprocessor arbitration in computer architecture and organization, and the subject code is 23ECE 503. And let us know introduction about interprocessor arbitration. Uh, Modern computers often have more than one processor working together to boost the performance. Since these processors share memory and input-output devices, they must take turns using them. Interprocessor arbitration is the process that manages this sharing. It decides which processor can use a common resource at any time, preventing the clashes or data errors. This coordination not only avoids the system problems but also keep the whole system runs smoothly, efficiently, improving overall the speed and the throughput. And next, need for arbitration. When several processors try to access same resource at once, conflicts can happen. Without a proper arbitration system, data corruption or system crashes can occur. Arbitration can determine which processor gets priority at moment, and it prevents the bus contention and ensures only one processor control at the bus at a time, provides a fair and uh, predictable access and to share the resources. And let us know the shared resources in multiprocessor systems. uh, in multiprocessor systems, resources are shared like the system bus, memory modules, input output devices, catch lines and buffers. Arbitration mainly focus on managing bus accesses, which carries the address, data and control system. Efficient arbitration ensure these resources used properly without any delays or interference. Let us know the basic concept of the arbitration. The main concepts that manage the access is called bus arbiter. It decides which processor becomes the bus master temporarily. The arbiter receives the request signals and sends the grind signals based on the priority. Once a processor finishes its task, control of the bus goes back to the arbiter for the reassignments. Let us know the types of orbitant schemes. There are three types of orbitant schemes. Centralized orbitation, which helps to maintain one main control handles all the requests, and distributed orbitation is the second one. Every processor takes part equally and participate equally in decision making. And third one is hybrid orbitation, combination of centralized and distributed approaches. Each type has its own balance between the simplicity, speed, fairness, depending on the system design. Let us know the centralized orbitation. In this method, a single orbiter controls the entire bus. Processor sends request to it and it grants access using a priority system. Common examples include the daisy chain, fixed priority, rotating priority methods. It's simple and cost effective, but since everything depends on one controller, it can become a bottleneck or a single of failure when many processor request access at once. Distributed orbitation. Here each processor has its own orbitation logic, meaning that it means decisions are made collectively instead of relying on one controller. This removes the risk of a single point of failure and improves the scalability. However, it's more complex to design the coordinate because all processors must communicate their status efficiently to make fair decisions about who gets access next. Orbitation techniques. There are several ways orbitations can perform a daisy chain method. Priority depends on how devices are connected. Polling method, and the controller checks each processor in order. And third one is independent request. Each process has the grant lines for each processor. Time slice orbitation. Every processor gets the bus for a fixed period of time. These methods differs in hardware complexity and how quickly access decisions are made. Performance consideration. To evaluate the arbitration consideration, we look at the key factors: latency, fairness, throughput, priority inversion. When it comes to latency, how long a processor waits for access, and fairness is nothing but ensuring equality opportunity for all the processors. Throughput, how efficiently the system uses resources, and the priority inversion, lower priority task blocking higher priority one must be avoided. Applications of interprocessor arbitration, multiprocessor systems, embedded systems, network processors, server and data center systems. And finally, the conclusion is to sum up: the interprocessor arbitrations is essential in any system where processor share resources. It maintains harmony and order by granting access fairly and efficiently. Uh, this system will continue to play a key role in ensuring the stable and high performance computing. Thank you.